In this video, we're going to be learning about solution stoichiometry. Now, solution stoichiometry is similar to any other stoichiometry. The only new twist here is that we're going to use molarity to get between the moles of a substance in solution and the volume of a solution. So say we've got this problem here where, let's see, we've got hydrochloric acid reacting with calcium hydroxide. And we're trying to fully neutralize 100 milliliters of 0.15 molar calcium hydroxide. And we're asked about what volume of hydrochloric acid at a given concentration of 0.200 molar is required for this to happen. So I'm going to use my starting point of the amount of calcium hydroxide given. That's the 100 milliliters. And I know that I'm asked what volume, how many liters of HCl is necessary to do this reaction. So I know that if I'm going to get from liters of one substance to liters of another, I have to go through moles. And now I just have to figure out, the mole-mole ratio, that's easy enough. This comes straight from the equation. But I need to figure out how do I get from liters to moles here and from moles to liters. And this is where I use those molarities that were given. So I know that we have a 0.15 molar solution of calcium hydroxide, and I need to use that as my bridge from liters of calcium hydroxide to moles. Similarly, as I get from moles to liters of hydrochloric acid, I do need to use this 0.200 molar that's given to us in the problem. So now that I've got this all mapped out, I just use dimensional analysis. We start off with what we're given, the 0.100 liters of calcium hydroxide, and we're going to multiply by the molarity, and then we're going to multiply by the mole ratio of 2 HCl's to 1 CaOH2, and then we'll multiply by the reciprocal of the molarity of HCl so that we have liters as the numerator and that the moles of HCl cancel out. And that ultimately brings us to 0.15 liters of HCl. So it's 0.15 liters or 150 milliliters of hydrochloric acid will be required to react with the amount of calcium hydroxide given. So that's that. Next, we're going to find the concentration of calcium hydroxide in a different reaction. And so this is something that's a bit different from what we've done previously, because concentration we've already addressed before. That's a conversion factor. So in this case, we're actually solving for a conversion factor. And if we know that it takes 50.0 mils of 0.200 molar HCl to neutralize 25 milliliters of an unknown concentration of CaOH2, what we need to do is say, all right, we've got the 50 milliliters of HCl, we've got the 25 milliliters of calcium hydroxide, and since we know the concentration of HCl, we can actually use that as our starting point, going from the 50 mils of HCl using the concentration of HCl given, which is 0.200 moles per liter. And that brings us in this direction. So by this point, I think the mapping probably makes a lot of sense. We still have to figure out how we're going to figure out that conversion factor. And here's my advice on that. So we're going to start with the 50 mils, multiply it by the molarity of the HCl, and then we will multiply that by the mole ratio. So we have the liters canceling out, we have the moles of HCl canceling out, and at this point, we are at the moles of calcium hydroxide. Now, if you wanted to, you could multiply this by however 1 liter over whatever unknown X molarity equals our 25 milliliters or 0.25 liters, but that's a little bit messy, I think. So what I do is I just stop here. I stop my dimensional analysis at the 0.005 moles of CaOH2 that we get here. And uh, I'm going to treat the rest of this kind of as a separate problem. So what I'm going to do is I'm going to say I know that the definition of molarity is moles per liter. So I'm going to put that here and say that my unknown X molarity is equal to the known moles that we just calculated, the 0.005 moles of calcium hydroxide divided by the 0.025 liters of calcium hydroxide, and it's right there for me. So I just substitute in here, and what I end up with is that the molarity of the calcium hydroxide solution is 0.200 moles per liter. And that's how I would solve for molarity when given other information about a solution. So that's all for solution stoichiometry. Hope the video's helped. Feel free to leave any questions or comments in the comment section below. Thanks for watching.